So you've seen AIs use all these cool external tools, right? But how does that actually work? Well, it's not magic. It's a protocol called MCP, and here's the best part. Its entire architecture, it just boils down to three core components. Seriously, that's it. If you can get your head around these three parts, you'll understand the whole system. So let's break it down. Yeah, this is really the core question, isn't it? I mean, when you ask an AI, hey, go query my database or create a GitHub issue for this, what is actually happening under the hood? It's all thanks to this really clever architecture, one that's designed to let basically any AI application talk to any tool in a totally standardized way. And that whole architecture, believe it or not, is built on just three key players. That's it, three. Now, to make this all really click, we're going to use a super simple analogy. A restaurant. Just picture it. You've got a customer who wants food, a waiter who takes the order, and a kitchen that cooks it up. Keep that picture in your head as we go through each part. All right, let's dive in and meet our first participant, the host. Now, going back to our restaurant analogy, this is the customer. And you know what? This is the part of the system you're probably already the most familiar with. Okay, so in our restaurant, the host is the customer. Simple as that. It's the AI application you're actually using, like Claude Desktop or VS Code. The customer, right? They know exactly what they want. They might say, hey, query my database, but they're not about to walk into the kitchen themselves to get it done. The host is simply where the whole request kicks off. So if the customer, our host, makes a request, who's going to take that order to the kitchen? Well, that brings us right to our second component, the client. You guessed it, the client is our waiter. Now listen up, because this is probably the most important thing to get straight. The client lives inside the host. It is not a separate app you have to install. Think of it like a built-in messenger that grabs the host's request and knows exactly how to speak that special MCP language to the outside world. And that brings us to the final piece of our puzzle. The waiter has the order. So where do they go now? They need to take it to the place where all the magic happens, where the work actually gets done. And that place is the server. Exactly. The server is our kitchen. This is the program that has all the goodies, the actual tools and the data. So for example, it could be a GitHub server that knows all about creating issues, or maybe a database server that's an expert at running queries. And here's a cool thing. Just like a kitchen can be right in the back of the restaurant or a delivery-only place across town, an MCP server can be running locally right there on your machine, or it could be somewhere out there in the cloud. So what exactly is on the menu in this kitchen? Well, a server offers three main things. And in the MCP world, they call these primitives. First, you've got tools. These are actions the AI can actually take, like making an API call. Then you have resources. This is the data the AI can read, think files or database records. And finally, you have prompts. These are basically reusable templates, kind of like recipes for common tasks. Okay, quick recap. We've met our customer, the host. We've met our waiter, the client. And we've met our kitcher, the server. We even know what's on the menu. So now let's get into the interesting part. How do they all talk to each other to make sure the right order gets delivered every single time? Well, they all use a standardized language called JSON RPC 2.0. Now, don't worry, you don't need to know all the nitty-gritty details. Just think of it like a perfectly structured order ticket at the restaurant. It has a spot that clearly says, here is the request, and another spot that says, here is the response. This simple structure just ensures that the client and the server always understand each other perfectly. No mix-ups. But how does that order ticket physically get from the waiter to the kitchen? Great question. There are basically two main routes. If the kitchen, our server, is right there in the building, so to speak, they communicate directly using something called STDIO. But if it's a remote kitchen, somewhere across the internet, they'll use HTTP. That's really it. It's just two different delivery methods for the exact same message. And this flow is so brilliant in its simplicity. Let's just walk through a real example, step by step. Okay, step 1. The host app, your AI, identifies a need. Step 2. The client living inside it sends a perfectly structured tools/call request over to the server. 3. The server gets to work and does the heavy lifting. It queries the database. 4. The server sends the result back. And finally, 5. The client gets that result and passes it right back to the host, which then shows it to you. See that? The request flows down and the response flows right back up. So elegant. Okay, so you might be thinking, why bother with all this separation, right? Why have a host, a client, and a server? Why not just, build a direct connection from the app to the tool and call it a day? Well, the answer to that why is actually incredibly powerful. So the inspiration for this design is just fantastic. It comes from something called the Language Server Protocol, or LSP. Now, think about this. Before LSP came along, if you wanted to add a new programming language to, say, 10 different code editors, you had to write 10 completely unique extensions. What a nightmare. But with LSP, you just write one language server and boom, all 10 editors can use it. MCP is doing the exact same thing before AI. You build one tool server and now any AI application can connect to it. It's a game changer. And that, right there, is the big payoff. This whole architecture creates this beautiful, composable, plug-and-play ecosystem. It means anyone can build a tool server. Anyone can build a host application. And as long as they both speak the language of MCP, they can just work together. It also keeps things really clean and secure, because you have these clear roles and specific points where you, the user, have to give explicit consent, which really brings it all back to the simple but super powerful mission statement from the official spec. See, this isn't about just one specific app or one specific tool. No, it's about creating the standard, the common ground that allows the entire AI ecosystem to connect, to communicate, and to grow together. So now that you get it, the three core components, the host, the client, and the server, it really makes you think, doesn't it? In this new world of standardized, plug-and-play AI tools that's opening up, what's the very first thing you would want to connect to your favorite AI application? What's that one tool that would be a total game changer for you?